Brad Williams, Frugal Finance, Perpetuities. In simple terms, a perpetuity is like getting the same amount of money regularly, forever. Usually in business, we deal with a set number of payments over time, but sometimes for really long projects like building bridges or setting up funds that last for 50 years or more, I talk about payments that go on forever. That's a perpetuity. Console bonds, for example, would be a perpetuity. Think Amazon or Apple that issued a perpetuity, I believe. This is 2024. One of the U.S. publicly traded companies issued a perpetuity. And I can't remember. If you put an amount of money, let's call it P, into a fund that earns interest, let's call it I, and you can withdraw a fixed amount, let's call it A, regularly from it forever, then there's a special relationship between P, A, and I. So P and I equals A. Thus, as depicted in figures 4.3, P is a present value that will pay out equal payments of size A indefinitely if the interest rate per period is I. The present value P is stated as the capitalized worth of A, the size of each of these perpetual payments. What deposit at time zero into a fund paying 9.5% annually is required in order to pay out or receive $5,000 each year forever? The solution is straightforward. P equals A divided by I equals $5,000 divided by 0.095 equals 572,631. I think that's supposed to be 52631. Over here is the math. So we got $5,000 divided by 0.95. So if you can get a 9.5% interest, all you have to do is put in $52,631 and you're going to get $5,000 each year forever. Here we go, the capital recovery formula. Capital recovery formula. You purchased a computer for $82,000 with a 7-year life, a $5,000 salvage value, and interest cost of 15%. What is the present value? Here we have payments. We're solving for payment here. So we're going to use payment. We're going to plug and chug here. Here is this number reconciled. So we're going to use payments. And then if you get stuck, you can just go in here, just click the function, and then we're going to have these rules. So your input is going to be rate, number of periods, present value. This is given. And you're going, well, we're trying to solve for present value. We have to discount this $82,000. We need a starting point. The question is, what is the present value of this $80,000 with a $5,000 salvage value? So then you put in this future value. In other words, that is the number that we are going to discount the 82, and then we're going to look at the interest that this salvage value would earn. So in the end, it's $19,258. The reason being, you have to take this future value, $15,000, 7, take a future value here. I'm just going to show you here. I'm going to try to explain this. We're going to take the future value. What's this future value worth? We took 15, 7, M20, 82. Right here, I changed this around. What this should be is salvage value is 19,258, this number here, and then the 82,000. M20, 15, 7, 19,258. Why is it showing $5,000? The present value is going to be this 19,25775 of this $82,000 purchase. Keep in mind, it's 7 years, 15% with a $5,000 salvage value. If you have the purchase price and the present value, what's the salvage value? $5,000. If you have salvage value and the present value, you can compute what the purchase price is. Remember, we're using the payment here. We're going to use future value here to find the salvage value. We're going to find the present value. Then we're going to use number of payments. And again, this is just a matter of working through Excel. You're going to have to work through, I'm not going to explain all of the different functions within Excel. There's too many. And that's part of the task here. That's the learning part of these sessions. The old school method, you can plug and chug, as I showed in the other examples, or you can use Excel, whatever works for you. Lastly, consider the two cash flows and comparing A and B below. The two alternatives are one-shot investments. We're unable to predict what investment alternatives will be available in the future, but we do anticipate that cash flows can be reinvested and earn a 15% return. What investment would you choose and why? Keep in mind, we're looking at the reinvestment rate. Here we have this project purchase. Don't worry about the PV. We're going to have this net present value, right? And everything should reconcile. But here are the staggering numbers. We have an internal rate of return. So could you imagine? Your output is only $4,000, but your income is this staggering, look at this income with an internal rate of return of 81%. That is probably a one-shot deal. This is just purely hypothetical. So the question then begs, you have a 4-year deal versus a 6-year deal. You have the reinvestment rate, but where are you going to get an 81% return? And then the second project is a 44.62% return. And the standard deviation of income on the longer investment is nearly 3 times that of the first. So what would you do? I can't answer the question, and I'm not going to even give you a tip or hint as to what I would do. That's the question I pose. Let me know, what's the better investment? Brad Williams, Frugal Finance. Thanks for watching.